I was ordering dessert the other night and saw something called a supersonic brownie bomb, which, got me thinking about weird names.
Yeah. Yeah.
But I think I found an astronomical object that might just top it. Today, we're diving into something with an absolutely wild name. Dracula's Chivito.
It sounds bizarre, I know, but it's actually the perfect name. It tells you so much about what it looks like and even the story behind its discovery.
Okay, I'm intrigued. So let's get into it. The object is IRES 23077 plus 6707. Visually, in the photos from Hubble, it's just stunning.
It really is. It has this cosmic butterfly look.
Exactly. This dark band right down the middle, cutting off the light from a young star, and then these bright nebulas on either side. So where on earth did Dracula's Chivito or Drachi come from?
It's a great story. So it's a tribute, really, to another famous disc called Gomez's Hamburger.
Okay.
But this one mashes up the backgrounds of the two main authors. One of them, Herbig A, is from Transylvania, and he spotted these faint, wispy things coming off the disc that looked a bit like, well, fangs.
No way. So that's the Dracula part.
That's the Dracula part. And his co-author, Ana Mascara, is from Uruguay. So she added the Chivito, which is this really famous Uruguayan steak sandwich.
So we have Transylvanian fangs and an Uruguayan sandwich.
Yeah.
In space.
Yep.
I love it. But, okay, humor aside, this isn't just any old disk, right? The sources say the star at the center is a big one.
Oh, it's a monster. It's a young Herbig A star. So much hotter, much brighter and bigger than our sun. We're talking 1.5 to 2 times the mass of our sun.
And the disk itself is just immense.
The scale is what really challenges our models. Based on its distance, which is about 300 parsecs, we think the radius is something like 1,650 astronomical units. It's gigantic.
That's rare, isn't it?
It is. Drachi is the largest of only 3 known edge-on disks around a star this massive. It's a very exclusive club.
With a site like that, so complex, how did they know for sure it was a planet-forming disk and not, say, a planetary nebula, a dying star?
That was the crucial step. For a while, that was a real possibility. But then the Submillimeter array, the SMA, made these critical observations. It detected carbon monoxide gas.
And the gas was moving in a specific way.
Exactly. It showed clear Keplerian rotation. The gas was orbiting the star, following Kepler's laws, just like a planet would.
Yeah.
It confirmed it.
Right.
This is a genuine rotating planet-forming disk.
Wow. I mean, pulling that faint signal out of all the noise to prove something is orbiting. That requires incredible data analysis. It actually reminds me a bit of how businesses are trying to make sense of their own complex data streams.
That's a great analogy.
And speaking of that, if you need help with AI training, automation, integration, or software development, and want to uncover where agents could make the most impact,
So getting back to Drachi, what we've found with all these instruments, the SMA, NOEMA, Hubble, is that this giant cradle is dynamically very complex. It is not a simple, smooth disk.
So all that cosmic chaos we expect to see, it's on full display here.
It absolutely is. The data shows clear evidence of rings, a central cavity, which suggests planets might already be forming and clearing out their paths. But the really strange part is a strong radial asymmetry. The northern side is just consistently brighter than the southern side.
What does that mean?
It probably means the disk is eccentric, so it's not a perfect circle, but more of an oval, maybe with an eccentricity around 0.26. It's lopsided.
Which has to make you wonder, right, how do planets even form when their birthplace is so messy and off-kilter?
And the Hubble images confirm all that activity. We can see these bright, wispy filaments stretching way out from the disk lobes. It points to a lot of gravitational stirring, maybe even instability in the disk. It's a turbulent environment.
So what this all means for you, listening, is that even these massive, beautiful cradles for new worlds are messy. They're complex. And I think that's actually really hopeful. It shows the universe's incredible ability to create structure, to create future planets, even from these really dynamic, chaotic beginnings.
I completely agree. And because we don't see any active jets coming from it, we think Drachi is a more evolved, a Class 2 disk. Its really complex, eccentric structure might just be showing us a crucial, advanced stage of giant planet formation that we almost never get to see so clearly from this edge-on view. It's a window into how stability can emerge from all that cosmic motion.
What a fantastic object. If you enjoyed learning about the birth of massive star systems, please subscribe to the show. Hey, leave us a 5-star review if you can. It really does help get the word out. Thanks for tuning in.